All right, guys, before we get started, are there any questions over any of the assignments thus far? Questions on any of the homework assignments? We can look that up here in a little bit. Now, what we're doing today is the last method for solving quadratics. Out of all the methods that we've had so far, the first one we had was factoring. We factored it into two sets of parentheses, set equal to 0. If two things multiply together equal 0, one of them must be 0. The second method we had was
the iced coffee for the softball fundraisers are in the office at this time. So if anyone who is wanting one, they need to come and pick it up. Thank you.
So the different methods we've had so far, we started with, first one was factoring. Then we went over how to solve them by graphing. Whenever they cross the x-axis, whatever value of x makes the y value be 0 is a solution. We followed that up with the square root method. In factoring, graphing, and the square root method work on some but not all. Because if it is factorable, then we can solve it by factoring. If it does cross the x-axis, then we can solve it by graphing, as long as it is a nice number. But the first method that worked every single time was completing the square. And completing the square works every single time, no matter what the quadratic is. It could have real solutions, it could have imaginary solutions, it could have rational or irrational solutions, and completing the square will always work. There is one other method that works every single time, and that is the quadratic formula. And that's what we're going to be doing today, is the quadratic formula. Now, we're not going to go about finding the quadratic formula. I'm going to go on and tell you what the quadratic formula is. If we let a, b, and c be real numbers such that a is not equal to 0, then the solutions for any quadratic equation, ax squared plus bx plus c equals 0, we do have to set it equal to 0, is given to us by this formula here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So, if we're using the quadratic formula, our x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. The first thing we need to do is get the quadratic equation equal to 0. So here we have x squared plus 3x is equal to 5. So to get this equation equal to 0, we need 2 minus 5 from both sides. If 0 would give us x squared plus 3x minus 5 is equal to 0. Questions on any of this here so far? Now, to use the quadratic formula, all we got to do is plug in the values of a, b, and c and simplify. So if we look at this here, a, in our case, is what? 1. A is 1. B is 3. C is negative 5. Because A is positive 1, B is positive 3, C is negative 5. So when we look at the formula, x is equal to negative b. We plug in the value b, which is 3, plus or minus the square root of. First thing inside the radical is b squared, so we would have 3 squared minus 4 times a, well, a is 1 times c is negative 5. All over 2 times a. And in our case, it'd be 2 times 1. Questions on this so far? Now we just need to simplify. So the first thing we have is negative 3. Well, that would just be negative 3. The denominator is 2 times 1, which gives us 2. Now the next thing we can simplify is this 3 squared minus 4 times 1 times negative 5. I would do that all at once in the calculator, because we can grab the calculator. And I would type everything that's inside the radical, not the radical, in 3 squared minus 4 times 1 times negative 5. I would type it in exactly as we have it, with parentheses and all. Hit enter, and it tells us it is 29. Questions on this so far? Now the next place that we can simplify is the square root of 29. Because if that reduces, we need to reduce it. So we can say second square root 29 is square root of 29. There is no way to simplify this any further. That's the answer. Questions on this here? Are you ready for the next one? 3x squared plus 4x equals 10. Yes, if we're using the quadratic formula, we need to get this equal to 0. That's the first main step, is getting this equal to 0. So we have 3x squared plus 4x minus 10 is equal to 0. And again, it might be helpful to list out A, B, and C. It's not a necessity. But looking at this quadratic here, what's the value of A? Value of B. C is negative 10. So the quadratic formula, negative B plus or minus the square root of B squared minus 4AC all over 2A. Negative. So we can go on and start plugging our values in. Well, the value of B is 4, so we'll have negative 4 plus or minus the square root of B squared. So it's 4 squared minus 4 AC. Well, our A value is, and our C value is negative 10. All over 2 times A, which would be 2 times 3. So with this formula here, we get the equation equal to 0, plug in the values of A, B, and C into the formula, and now we'll simplify. So we have negative 4, plus or minus. Well, the other easy one that we can do is 2 times 3, which is 6. And again, this is something I do even when I solve these. I figure out what's inside the radical first before I take the square root of it. So we have 4 squared minus 4 times 3 times negative 10, which gives us 136. It does indeed. Any questions on this here? So, the next thing I would do in this calculator is to take the square root of 136, which is 2 square root of 34. So that means x is equal to negative 4 plus or minus 2 square root of 34 all over 6. The 2 times a. So 2 times 3 gave us 6. Is there a greatest common factor between the two terms on top? 4 and 2 share a common factor of. Does it share it in common with the denominator? Well, yes. All three do have a common factor of 2. So we can simplify this. I'm going to do the little bit longer way in that I'm going to factor the 2 out of the numerator. So if I factor a 2 out of negative 4, we divide negative 4 by 2, we get negative 2. If I factor a 2 out of 2 square root of 34, we're just left with the square root of 34. Does this make sense? No? Yeah. So I'm pulling that 2 out. I'm reducing each one by a factor of 2. It'd be 6 for now. And the reason we're doing this is because we can reduce it. Leaving it in that form is the same way as saying that the final answer is 4/6. Can we reduce 4/6? Yes. By a factor of 2. The same thing's true here because we share that common factor of 2 in all of them. We're going to reduce it out. We're going to simplify it now. Now, one way to see that is I'm going to factor the 2 out of the numerator. I'm going to pull it out of both terms. Because 2 times negative 2 plus or minus square root of 34 is the same as negative 4 plus or minus 2 square root of 34. Because if I multiplied it back through, we would get back to this here. We can see that, yes? So the reason I pulled it out, or to write it this way, is because we do have 2 over 6. 2 over 6 does reduce to 1/3, yes? So the denominator here would be 3. This 2 is now 1, it's gone, leaving us just with our negative 2 plus or minus the square root of 34. So all we did was reduce it by that there. And the main way we could reduce it was because the 2 numerators shared a common factor of 2, and the 6 on bottom shared it as well. For the most part, as long, and especially on the test, as long as you can get to the negative 4 plus or minus 2 square root of 34 over 6, that's what I'm looking for. It would be nice if you could be able to get it to the final one, but I want you to at least get it there. Questions on this here? Let's look at the next one. X squared minus 6x plus 4. Is it equal to 0? So the value of A is, the value of B is, and the value of C is 4. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, since we do have our a, b, and c, we can plug them in. So we'll say negative b, so negative negative 6, plus or minus the square root of negative 6 squared minus 4. Our a value is 1, and our c value is 4. All over 2 times a, which would be 2 times 1. Questions on how we plugged any of this in? Our simplifying negative 6 is just 6, positive 6. The denominator 2 times 1 is 2. And again, I would plug everything inside the radical into the calculator, but I would do it without the radical. Parentheses, negative 6 squared minus 4 times 1 times 4 is 20. Now we need to see if the square root of 20 will reduce, and it will, to 2 square root of 2 square root of 5. Questions on this here? Do the two numerators and the denominator, do all three of those spots share a common factor? 2. So we could go through that same method. Let's do it a little differently. We can't do plus or minus in the calculator because that's 2 different signs. But we do have 6 plus 2 square root of 5 all over 2, yes? So square root of 5 plus 3, or we could say that it is 3 plus the square root of 5. Because I normally put the square root second. I'm going to do it again. But this time, our other sign was minus. Yeah, so we're saying 3 minus the square root of 5. Three plus or minus square root of 5, because that's the only difference between them. Not that I know of. Right, because we're saying that we have 2 separate fractions here. Really, that x is equal to 6 halves plus or minus 2 square root of 5 over 2. In the division of 2, 6 over 2 becomes 3. 2 over 2 is 1, so we get this here. It does cancel out. On the last one, we could have done a similar thing and said x is equal to negative 4, 6 plus or minus 2 square root of 34 over 6. Negative 4, 6 becomes negative 2/3. And the other one becomes square root of 34/3, which is the same as what we had. It's just put it back together because of that division of 2. Questions on any of this so far? The only thing that really makes this somewhat tricky is that simplification at the end. But for the most part, the calculator can help us some. We're ready for the next one. So can we go on and grab A, B, and C from how the equation is set up right now? No, we need to get this equal to what? So we will add 7x to both sides, telling us that we have 2x squared plus 7x plus 4 is equal to 0. And before you start any of these here, I would get them equal to 0. Now the value of A in our case is, value of B is 7 and C is 4. So x is equal to negative B.
How does it because the x's they have to come before like that doesn't have an x?
Yep. So we always order them in terms of descending power. So x squared is first, x is second, term without x is always third. So now we can plug our values in. So negative b would be negative 7 plus or minus b squared, so 7 squared, minus 4 times a, which is 2, times c, which is 4, all over 2 times a, which is 2 times 2. Questions on this here? Now when we simplify, our negative 7 will just become, well, negative 7. 2 times 2 gives us 4. Inside the radical, our 7 squared minus 4 times 2 times 4. 7 squared minus 4 times 2 times 4 is 17. It does not factor. So x is equal to negative 7 plus or minus the square root of 17 all over 4. That's it. Questions on this here? We're ready to see another one. Five x squared equals x plus 8. So exactly. We could subtract the 5x squared from both sides. We could also have subtracted the x and subtracted the 8. Either way works. Because the main thing is we want this equal to 0. A is, B is, C is 8. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b. So that'd be negative 1 plus or minus the square root of 1 squared minus 4 times a times c all over 2a. And as we simplify, our negative 1 is just going to become negative 1. The denominator 2 times negative 5 would be negative 10. Our next step is to simplify what's inside the radical. So our 1 squared minus 4 times negative 5 times 8. Which gives us 161. Well, it'll be good to see if 161 reduces. It does not. There is one simplification I want to do. I want to get rid of that negative in the bottom. of the fraction, that negative 10. And to do that, it's not a difficult process, but we're going to take this negative and apply it to the numerator. We're going to take it and multiply it through the numerator.
So it just adds it and
It becomes positive 1. So we have plus or minus 161, yes? When we multiply a negative times a positive, it becomes negative, yes? So the positive on top becomes negative. But we also have the negative, yes?
this is negative or positive.
So the plus or minus, the plus becomes minus, the minus becomes plus, so it stays the same. So the plus and minus essentially flip, which still gives us plus and minus. Now, if we wanted to avoid that, especially with the signs, what we would have done is at the beginning here is I would have divided the whole thing by negative 1. We would have still got the same answer, but we wouldn't have to get rid of the negative out of the bottom of the fraction. Because it would have made A positive 5, B negative 1, and C negative 8, but we still would have got the same answer. Questions on this here? Questions on any of this so far?
How do you apply that to the yeah.
So we took the negative out and multiplied that negative 1, because it's really negative 1 times 10. We applied the negative to the numerator.
All right.
Solve 25x squared minus 8x is equal to 12x minus 4. Well, if we're using the quadratic formula, we need this equal to what? 0. So that's the first thing we can move. So we subtract 12x from both sides first, which does give us 25x squared minus 20x is equal to, then we can add 4. So I'm going to say we have 25x squared minus 20x plus 4 is equal to 0. Now the value of A in this case is, value of B is, and C is. So now we plug it into our quadratic formula. X is equal to negative B. Well, B in our case is negative 20. Plus or minus B squared, so negative 20 squared, minus 4 times A, which is 25 in our case, times C, which is 4. All over 2 times A, 2 times 25. Now we will do some of the simplifying. Negative 20 would be 20, plus or minus. 2 times 25 is 50. Now, inside the radical, we have negative 20 squared, minus 4 times 25 times 4. Yes? And that gives us 0. Yay. Plus or minus the square root of 0.
Can you go back to the one you put in?
So the negative 20, we do need it in parentheses.
I have all of it in parentheses.
Ah. Because since it saw it as -4 instead of -4, it multiplied everything together instead of -20 squared, and then subtracting it from the product of 4 times 25 times 4.
Thank you.
You're welcome.
Figure out why I was like,
Now, the square root of 0 is 0. And exactly as you were saying, 20 plus 0 is what?
wait, 0?
20 plus 0 is 20, yes? What's 20 minus 0?
20.
So really, this is saying that we have 20 over 50. Now, we still technically have two solutions. It's just one of them is 2/5, and the other is 20 over 50, which is just 2/5. They're both 2/5. We do have two answers. They're just the same answer. They're both 2/5. Questions on this here? Need to get it equal to 0, so we will subtract 13. Since 13 is positive, we would subtract it, giving us x squared plus 4x minus 13 is equal to 0. Yes? Now, since that first term's negative, and we saw previously what happens with that, kind of throws an issue at the end, yes? Let's get rid of it. Because I can divide every term by -1. Because negative x squared divided by -1 makes it x squared. 4x divided by -1 is -4x. Negative 13 divided by -1 is plus 13 is equal to 0. Doing this helps us because the value of A is now 1. The value of B is now -4, and the value of C is 13. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So our negative b would be -4 plus or minus. In the parentheses, we had -4 squared times 4 times a times c all over 2 times a. Well, our -4 becomes +4, yes? Our denominator, 2 times 1 is 2. Now, we do need to simplify the radical, yes? Now, up to this point, it's kind of been wondering why we don't do this all at once. -4 squared minus 4 times 1 times 13. -4 squared minus 4 times 1 times 13. Because it seems it'd be a lot easier to just do it all at once. I'm going to remove the radical. What do we get? -36, yes? The 30xs, which does great with radicals, cannot have a negative inside of a radical. It can't do imaginary numbers. That's why I always do it in parts. It's just on the off chance we do get that negative. Because the negative inside this radical is going to come out as I. And the square root of 36 would be? So we have 4 plus or minus 6i over 2. So this one here, the graphing calculator will do it a little bit better than we can, or the yellow calculator can. 2 plus 6i over 2. 1 plus 3i, yes? Well, the other one would be 4 and 6. Yes, thank you. Let's try that again. 4 plus 6i, which should be 2 plus 3i, yes? Well, the only difference between it and the other solution is that the plus is not a plus, it is a minus. So we can really say that this reduces to 2 plus or minus 3i. And that's it. Questions on this here? Questions on any of this so far? Now, this is the last bit. We're going to run right up to the bell, and that's not terrible. Is the last bit's nothing huge. It's nothing additional that we're really adding on to it. Because the types of solutions that we had, especially the last two, the last one we had imaginary. We had complex solutions, yes? But where the complex solutions came from is this term here, what we call the discriminant. Because when that b squared minus 4ac is less than 0, we have two complex solutions, two imaginary solutions. When this b squared minus 4ac was 0, we got 0 inside the radical, we got one real solution. We got one number, it was 2/5. And when it's greater than 0, we get two real solutions. And it works that way every time. So if we look at A here, well, the value of A is 1, B is -6, and C is 10. So if I want to see what type of solutions I will get, I can look at the b squared minus 4ac, what we call the discriminant. Well, our value b is -6 minus 4 times a times c. And we can type this in, either calculator. So -6 squared minus 4 times 1 times, it was 10. And that gives us -4. So the discriminant's value for this here is -4. Is that greater than 0, equal to 0, or less than 0? It's less than 0. Since this is less than 0, we have two complex solutions. Right, because if it's asking for the discriminant, number of solutions, and what they are, this is what we're looking for. We're going to do another one. X squared minus 6x plus 9. A is still 1. B in this case is still -6, and C is 9. -6 squared minus 4 times A times C. So we're doing this almost the same equation, but instead of 10, we have 9. -6 squared minus 4 times A times C is 0. So the value of the discriminant this time is, and that is equal to, so the number of solutions we have is 1. We have one unique solution. And it would be a real. Be one real solution. The x-axis. So this is the one that hits it. The first one, the -4, is the one that doesn't cross it at all. Now I think we have a guess at what the last one's going to be. Greater than 0. So with our b squared minus 4ac, we'd have -6 squared minus 4 times 1 times 8. And again, once we get these values, we can plug them in. Negative 6 squared minus 4 times 1 times 8, which is 4. And since 4 is greater than 0, we have 2 real solutions. This one's where it crosses the graph in 2 places. And the issue, or the main way that we can tell this from one to the next on all 3, is because, again, when we plug this into the formula, let me get a different color, we're taking the square root of it, because it's negative b plus or minus the square root of b squared minus 4ac. Because if what's inside the radical is negative, square root of a negative is going to give us I. It's going to give us those complex solutions. As we saw, square root of 0 is just 0. It doesn't add or subtract anything, so we just get 1. And we take the square root of a positive number, we will have 2, the positive and negative case, real numbers, and they work out. Questions on this here? We kind of get how this works. Yes?
Yes.
Mm-hmm. We do have, oh, I went backwards there.
No.
6 through 16 even is using the quadratic formula to solve. And 21 through 24 is find the discriminant of this quadratic equation, determine the number and type of solutions. So for that there, all I'm looking for is what's the value of the discriminant, b squared minus 4ac. How many solutions do you have? 2 or 1, because either 2 complex, 2 real, or 1 real, and that's it. You're not actually solving 21 through 24. The ones that you will need to get answers to are 6 through 16 even. You will not have an actual solution for 21 through 24.